Hello and welcome back to the development of the Feersum scheme compiler. So in the last stream we were looking at changing the way that we represent environments so that they weren't quite as clunky. And the plan for today is to continue off that work and hopefully finish it. So I guess we should start off by looking at what we've already achieved. So most of the work that we've done so far is in the actual compile function. It's the emit part of the compiler. In this emit named lambda. So what we've added is this new build environment function, which creates a unique environment type for each lambda. So it's probably best if I get a Sharp Lab window up and start trying to explain what the idea is here. So the idea is, well, if we had a method which did a method in our language that took an int and returned an int, returned a function that took an int and returned an int. And we like this, and this one would did something like a plus return a plus b, and we returned here, we returned bar. In .NET, we can see that what happens is you get this display class generated, which has the captured value a as a field, and then this g bar is the actual body of the method. But the kind of code that we would have generated for that would have been something like we always had. So this is the C# one, and we can see how the C# one would have generated it. But what we would have done would be something like func int int a. Then we would have done new environment null 1 that's not a very good name. So we would have created a closure environment, and then we would have done closure environment dot slots to capture the value, and then we would have done return closure dot bar, for example. And then we would have generated a class called class environment, which would take an environment pointer to the parent and a size. And what we used to do is set parent equals parent, slots equals new, like this, and we would then have And for each type, so we'd have one single class that represented all capture environments. And every time we had a method that needed to access a capture environment, these need to be public. We would generate a method on the environment like this, public int bar, int a, int b, and this would do return slots 0 plus b, like this. Which would achieve the same thing, and when we've just got this one method, it's fine, but so this kind of works the same way as the display class. It's just not quite as optimized. The problem being twofold. If we have a look at the display class, it is just a field and a method, whereas our environment has that extra layer of indirection. So we can do inspect dot heap environment what is it, inspect dot stack. What am I doing wrong here? So they all need actual values. Layout. Could have sworn there's one that you gave it. Okay. Apparently there isn't. I thought there was one way you could get it to draw the layout of a type, but apparently not. Anyway, the point being that we then have this extra layer of indirection, because every time, instead of us being able to do slots, or instead of us being able to do like this dot a, we have to do this dot slots index, which is a whole bunch of extra IL that we need to do for every single access to the slots. So the advantage of this was that because we only had one environment type, we could do things like having this linked list of pointers, and we had like a uniform way of accessing the environment. But what we then changed to, so let's do an example again. So public, I'll copy and paste and then edit, because that's going to be quicker. So the new way of doing this was we'd have an environment here called like Feersum new env, based on the fact that this closure is called Feersum new. We know that this doesn't have a parent pointer, so we wouldn't give it a parent pointer because there's nothing to pass in, and we don't explicitly give it a size anymore. And then rather than us having a slots, we would have like env0 and just generate a field for each one of these. And then we'd say closure environment bar, and then let's go and show how that class would look. Instead, here, simmer down. It wouldn't take any of these. It wouldn't have a parent, and instead it would just have a public int env0. And then here we would do env0 plus b. And that achieves the same thing as this more general environment type, but specified to the case of the lambda. Then that means that if we had a different lambda that captured something different, we would generate a different environment for it. So say we had an alternate version of the function where you say Feersum captures true, which gave it two parameters, int a, int b, it would do a new environment called Feersum captures 2env, and it would put like A in 0, B in 1, and then down here we would have Feersum captures 2 environment, and then this one would be M1, and then this one would say maybe M0 minus M1, whatever the actual implementation of the lambda was. Really need to stop pressing save because it's absolutely annoying me. Right, then the idea here is these two environments are just specific to where they appear. So if we had a case where this was actually a method on this environment, we could have it where this one took Feersum new env as a parent pointer like this. And then we could have it so that we said like parent m0 plus r m0 plus b minus b, this, and then we say, so this is how we'd be able to like have environments that reference like chaining. Each environment explicitly tells you what its parent environment type is, which is fine. And that's kind of like what's happening in, if we have a look at env test, is our current environment test. We're doing foo and bar with plus, and in this case, we'll have an environment that would look a lot like the foo would look a lot like this environment. There's some new env where it would have one slot, and then bar would access it just like this, doing m0. But there's a few problems because bar needs to get foo. It technically needs to capture a link to the parent, which means that technically bar also has a closure environment. It's just empty and only contains the link. And for us, we've done a little bit of an optimization, which means that we never actually even use that link when it's in a leaf node. But if you were further down in the tree, you would still use that link. So the way you could imagine this is that quite often you would have, so say you had define maybe we have a, sorry about this, back in a second. Looks like my company sent me an advent calendar. So yeah, try and find an example of how you would end up with an environment that was empty. So how about if we had a function like define make foo. And make foo would contain, so make bar. Bar would maybe be, I need to not capture it. So maybe it takes it as a parameter and returns it. Maybe, yeah, I'll just get bar. And then we call like get bar here. Or we could actually even make it one more layer. So foo would return get bar, then we'd call that to get the thing and then call it env test. So what would happen here is that foo would have the environment that has a captured into it, and it would also have bar in it because bar then gets captured here. Get bar would have an environment that just contains a link to the parent so it can look up bar, and then we would return get bar. So in this case, we don't actually need a new environment just to allocate, just to have that link in it, but we'd still do. So the plan is that we're going to go into the compile function and add support for detecting the case where we have empty environments that are just being used for links. And then hopefully we can, when we are traversing up the tree, we'd be able to do it in a way where if we end up with one of these empty link environments, just skip it. That's the plan. I'm not sure whether or not we want env tests to be edited. Let's just undo all of that. So we start off here in build environment. So we already do a little bit of work to decide what the environment size is. And we can also do let captures parent. Well, we can work this out because if there is some captures, but the environment, but none of them are in this environment, and therefore the env size is 0, we know that it only captures its parent. So I guess what we do is we'd say like is, do we want to model this at the type level? Because at the moment we've got this env info structure. So I'm wondering whether or not the parent and type bit could be moved into some kind of enum. So an env info is going to be mutually recursive type with it's going to be the standard which takes type definition and a parent, or it is a link to another env info. Now, is that valid? F#? Probably not. Yeah, because we don't want these. So we say it's either standard, which has a type definition and a parent of info. Is that correct? No. Forget how to do the labels. We do that in the arguments in the program. Do we? Yes. Oh, we do of. I've not written F# in a whole week. So it's going to be standard of type definition parent env option or link of env info. And then instead of having the type definition here, we'll have like a kind. Which is going to be of type env kind. And we get rid of the parent. So to get the parent, we need to do get type is going to be function if it is no, we need to take the environment and we need to match and if the kind is standard and it has a type, we return the type. And if it is a link in we do get type inner. So we recurse down the link. That seems to work. And then get parent is just going to be match env.kind again. Why does it keep on changing to env-info? If it's standard, we return the parent. Otherwise, if it's a link, and we don't need the brackets there, I don't think. Then we return the get parent of the init. What's broken? Match with. Yeah. This needs to be rack. Yeah. That needs to be capital kind. Largely working though. Bunch of knock-on errors down here. If env-info parent is so create environment just creates a new instance of an environment if we need one. So I think what we can do here is we match the kind again, and it is a standard one. Then we basically do all the stuff that we previously did. Otherwise, we just do nothing. So we need to use tie instead of the env-info type. And we want to use parent here. So that looks like it would compile. So basically, we will create an instance in the environment if we don't have a link. But if we just got a link, then we can just keep using this pointer. That's the idea. And then if it is captured, so captured means we need to go up one level Well, we'll do that one second because I can see what on here. So when we're doing read from environment and write to environment, we're looking at the given environment info and we want to read or write from it one of its slot members. So we need to do a match here. Env info kind with, and then we want to check to see if it's a standard one. And if it is a standard environment, then we will emit a load field from the type at the given index. If it isn't a standard environment, then we will do ice. We can do ice, and we can say attempt to read from read. And it's going to be L IDX. And I guess we want to do the same kind of thing here, where that's instead writing to the environment. And then we say attempt to write to the link environment. We can move that inside there as well. Then, when we're doing walk capture chain, we want to first so I think this we want to let parent equals, and then we'll do a match expression on the end kind. If it's standard type parent, we will load this field. Oops. So we want to load fields to get from this type, from the current environment, to get the parent. And the parent is just going to be parent. I think we need to option unwrap it here. And then if it is a link, I think we can just return L. Right, so then parent and type. We want to say kind equals kind. I want to say let kind equals if env size, the environment size is 0, then this is a link. Like that. Parent tie, option unwrap, turn it into a link. Else, if it isn't, we need to do this bit. We need to make the environment type, find the container type, add it as a nested type, and then we need to return standard for parent. So for env tie, parent tie, so I think no. So this is going to be context environment, isn't it? And then this parent type is actually only needed in this bit here as well. If I get everything indented, that looks roughly like it's going to work. And then this is not how you make a tuple. So that's one fewer red squiggly. So here. Do we want to move the hoists inside as well? It would probably be easier to hoist if we did it inside create environment. Right now, we can probably get away with saying if this is some environment where kind standard I do standard as S. Yeah. And this is S dot type, maybe. Do we have to do 2 matches? We can do 2 matches. Match e dot kind with standard tie. Yeah, so if it's a link, we can also ignore it. And is this the last error? If this method has a capture environment, whoops, then add it as an instance method to the environment type. I think we need to do let parent tie equals utils get type parent. Then we can do parent tie here instead. That means we'll walk back up the links until we find the actual concrete environment is a link to. Well, I'd be very surprised if this works first time, but I'm ready for it. It's building. Let's make this big so we can see lots of green when all the tests pass. Any minute now. Here we go. Okay. Failed to think about something somewhere. How about time.scm called unwrap on a non? Feersum compiler line. Come on. Why don't you let me click on you? If env size is 0. Let's just change this into a match then. There's some environment. We'll create a link to that environment. Otherwise, we'll do ePrint fn fails to find think environment parent, and then we'll do the captured. What can we do here? I can just something like that. How does fail with do it? By it, I mean like, does the compiler know that ice doesn't return as well? Apparently. Let's try running that again. So which test was it that failed? Timed SCM. Good. Yeah, how on earth would we have got in there? The list's empty. Interesting. Do some more mapping down here then. So the environment is going to be match the mappings with, we get some and no mappings, then it's going to be none. So that's the case where there's nothing captured in this lambda. That's right. The case where we have some mappings captured. We'll do build env captured. Oh, come on. And none will return none. It's going to be caps because I can't type. So, how about now? Interesting. How about running the whole test suite? At the end of this, if this if we can get this working, I want to have a look at how the environment is represented in that env test, because we also ended up with like this little vestigial environment which was just for the link on the let me just get the env test up. We ended up with an environment type created for bar which just contained the link, and hopefully that will have disappeared. Okay, so the tests all passed, which is positive. And now let's look at IL spy. Show me the IL spec bin debug and test. So we have a type for the program. We have a nested type to represent the capture environment of lambda 0, which is this thing, foo. The type for lambda 0 has a field, m0, which is going to be for the argument a. In the constructor, it's just calling the parent constructor. Fine. Lambda 0, which is going to be bar. This, it loads the add, casts it to a function, loads the field from m0. Sorry, loads the field m0 from the outer environment, which it does by getting this pointer. Does element ref? What's that one? Why are we doing that? Oh, I see. Because we're building up the argument array, so we're creating a new array. The arguments, duping it, loading A from the environment, storing it, duping it, loading the constant 1 because we know we want to get B. Put it into index 1, storing that, and then calling the actual real add method. Then there's the thunk, which is the unpack, and then the library type itself has the foo field, and that's it. Yeah, we don't have the weird empty environment anymore. Let's try at the REPL. And no, I need to change the debug type. Let's try and prove that we can create links. And just have it work. Oh, let's do it here. So if we do that, then we can do define test. So if we give test A and B, and we do define do stuff. Do stuff is going to define things. And things is going to return C. So it's going to do plus A, B, C. So whenever we return, we call do stuff, it's going to return us things with 10 or something. And then we can just do stuff. So that should, in theory, mean you call a function with 2 arguments and you get is that even going to work? So you call do stuff, and do stuff's going to define things. And it's going to return things 12. So when you call do stuff, you'll end up with it returning. The idea being here that things references A and B in the outer environment, not in do stuff's environment. There's nothing in do stuff's environment. Actually, there's nothing in things environment as well. So we should end up with only one type for this environment. If I'd say display test 1, 2. I'll put some more new lines in as well. It's always easier. Run spec. Hello. This is env test. Well, that was interesting. Called unwrap on none. So we're doing an emit application. We're doing read from. Let's debug and find out where it goes wrong. Feersum compile spec test. Yep, we called unwrap and anon. Where did we call unwrap and anon? We called unwrap and anon from walk capture chain because get parent env context. What have we got? Context environment is null, which means it's none. So it's captured from environment 0, arg 0. Did we... So this is just a plain read. I think the problem here is that do stuff ends up without an environment. Because it doesn't capture anything. But it should have an environment type of link. Let's just have a quick look to verify that. So build environment. Yeah, build env. Pop breakpoint here. Rerun that, compile, and see if can't talk and type, and see when we're building the environment for do stuff, what happens. So what can I look? So name script body. Okay, let's just keep on step till this changes to what we care about. Script body lambda 0, that's foo. We want until it's like lambda 1. Lambda 0, lambda 0. Lambda 1, so this is going to be the outer one. Then we want lambda 1, lambda 0. Which he says. So root environment mappings is a list with a length of 0. Can we just give everything a link environment? I don't know. So standard environments can optionally have parents. Link environments always have to have parents. Do we want to relax statics? That seems... yeah. Failed to find the link environment. We won. Is here. I think we want to make a decision. And say match context environment. If there is some parent, return some it's just context environment map option map. Kind link key captured is going to be the empty list and local will be none. Maybe that'll work. Let's try out on the one that we know failed last time. Environment test. Well, it's not quite as bad. Nope, she doesn't want to jump up. Just wants scratches. Why? Let's do the debugger again. Try and see if we can work out from the state where we've gone wrong here. Let's wait for the error. So we're getting internal compiler error when we try to call get environment in a context which does not have an environment. It does have an environment, but the environment doesn't have a local. Yeah, the kind is link to kind standard. So is this where we try and read through? Okay. Yeah, this makes sense. So when we're making the instances, we need to switch based on the environment. I think we need better matching here. So I guess first thing you want to do here is say match context environment. Get an environment. Then we'll need to load the this pointer. Otherwise, we just do a method to instance func. So to load the this pointer, we need to know kind. And if it's a standard environment, we just want to do env dot local option unwrap. If it's not a standard environment, if it's a link, then we will load the this pointer from the current method instead. Codes dot load darg 0, because argument 0 would be this pointer. If it's a link. Nope, not that. This one. Wow, is that right? I think so. Test. Do stuff. Things. Let's just run all of the tasks. Run all the tests, find out what failed. So this is going to do 1 plus 2 plus 12, which is 15. Seeing a lot of green tests. Pass fail for the env test, that's acceptable because we've changed it. Gonna have to do an update snapshots. While we're waiting for that, let's have a review of what we've actually written. So, environment info now has a kind, which is either standard or link. That sounds good. Get type and get parent. Now walk the tree to get the appropriate thing. What is it? Control K, Control Alt S. That's potentially awkward. We'll find out whether or not I can do that in this next one. Create environment. create environment. It used to do if the parent was sum, then get the constructor, blah, blah, blah. But now it checks, and if the environment kind is standard, it does that. Otherwise, it doesn't do anything at all because there's no need. I'm just wondering, we just had a problem with the local for the, because we had to use load arg0 instead. I wonder whether or not instead of local being just an option of a variable declaration, should local be inside the kind? So you wouldn't be able to get the local if it wasn't a standard environment. Maybe. We'll come back and do that in a second. What is it? Control K, Control Alt S. Guess for stage, it works. So we used to just unwrap the parent, and then we used to index into the fields, and now we match on the types. So if we're walking a capture chain, we only need to look up the parent environment if there is a standard environment. Basically, like, we've already got the parent pointer. It is the current pointer. If it's a link environment, we're just putting everything on the same one. The same thing for read from environment, write to environment. We need to check to make sure. Control S, yeah. We need to make sure that it's a standard environment because you can't read or write from link environments because there's nothing in them. And when we're creating the parent pointer, we just fixed that up. Now, kind, we choose the kind based on whether or not the environment is empty or not. So if the environment is empty, we create a link environment. This is still not perfect because we've got the weirdness with down here when it's empty. How would you ever get into that place? I mean, I guess that's the reason why it's an internal compiler error. You could never ever get in there. I think I just need to look at it, and hopefully there'll be a moment of insight. So yeah, to create the environment, we look at the mappings. If it's empty, we see whether or not we have a parent, in which case we create a link. if we have some captures, we do this to work out the size of the environment and either create a link or a standard one, depending on whether or not it's empty. Maybe we want to do like the length check. Yeah, maybe we want to do the length check first. We used to have like a tri-state boolean for the length, where it used to, instead of being 0 or n, it used to be either none to indicate that no environment was required, some 0 to indicate that it was a link environment, and some n to indicate that it was a standard environment. It might be an idea to get that back again, because then we can switch over that down here. So how would you do that? You say if there was the captures, you'd get the environment size. And then you know if the environment size is 0, yeah, then you can do the link environment in one place. I'll try and come back to do that. Here we only do the captures if it's a standard environment. And we look at the parent type. What about the pass changes? And the output, we now have 15, but everything else is the same. Good. Thread. Linked cap environment. Don't create otherwise empty environments when only the parent captured. Instead, these methods can become instance methods on the parent environment instead. thread that it's pointer and void some overhead, I guess. So env size. How can we solve this? What we really want is build environment to take a size. Is this the only place that we talk about captured? Because we could probably simplify the situation a little bit. Ooh, I can see a huge simplification here. It's dawned on me. Has it? Well, let's get rid of captured first. See what breaks. Ah. This is just wanting to find the last field, I believe. Which is count -1. So that solves that problem. Down here, we're just initializing captured. And then down here, we can actually just use root.env mappings. And we can probably just do option map seek it. How am I chaining these two things together? Captured to seek iter like that. That must be iter. Yeah. And given that's just taking that and applying it to that, can I just do this? I can. Even better, we can probably do tie parent root.m mappings here and move this stuff into create environment. And this is going to take tie parent the env tie. Oh no, tie, because that matches what we've got down here. Type parent and captured. If we do that, we can get rid of this match again. Unindent this. Whoops. And then let's have this return the env. Then we don't have to modify it in here. Parent is going to be see, this thinks tie is type reference, so why is it saying it's indeterminate type? I think this should be This wants to go here. So we store the environment. Then we do the hoists, which is just going to be load lot env octoparam. This can just be it's not in use, it's used there. Captured instead. Captures parents instead. Then you can work out that's a bool. You can work out that is an option of some kind of list. This is going to be an option of env info. And captured is going to be an option of a list of storage list. So it's, I think incomplete. Why are you incomplete? Fair enough. I think that's going to be type definition instead. Good. Then down here where we use it, we say type parent. And you want to say e dot local is the local. Done by initialize environment, I guess we should call this. What are you upset about? Some. That wants to be there. That. That's better. Does it break things? do we use locals for? I reckon we can get rid of the kind, and I reckon we can move the local inside. I think we can pre-allocate that. So let's do initialize environment here. Instead. Let's do the old school way. Initialize environment. And inside here, instead of doing make temp, we'll do env local. Get rid of the return value now. Down here, we just do initialize environment. Then standard wants to have a local. Because there's always going to be a local for it to live in. It doesn't need to be optional. It doesn't need to be mutable. And info. Just get rid of that. So get local can be a function if it's standard local thingy thing, return the local. Some of the local, otherwise return none. So local's still going to be optional when you look it up like that. And this is going to be something type. Guess the type. This can just be function now. This can just be a function. When it's standard, we take parent. That works. just call it env.info. Because that makes far fewer errors. That should work now. That should work. That should work. I think. Expecting up. Why does walk capture chain expect env.info in AST node? Because it's doing .kind. Same here. If it is a local, we do load lock local. That's got rid of an unwrap. That's good. And here we can just do make temp. Can we? Takes an emit context. Why does it take an emit context? It's just making a variable definition and adding it to the body. So there's nothing particularly necessary about using make temp. So do env local, and we can say env tie is going to be, or env local variable definition env tie context dot method decal body variables add. This is what we want. To add it to the new method declaration. Whoops. And then here we can just return kind. Which then means here we just want this to be link, I believe. It's always nice when you get to the stage in refactoring where you're just endlessly hacking away at code. Reducing it down. How well did I do? well enough for it to compile. I'm going to rename envinfo to envkind as well because it just makes a lot more sense for it to be an enum called kind, not info. Capture environment kind. Capture environments are either standard environment containing fields used to store captured values or link environments represent the case when only parent environment is captured. In this case, we can should we move some of this onto the actual alternates? Maybe let's do that. So this would just become like this. Link environments represent the case is captured. In this case, we can just we can reuse parent type and pointer. Saves the cost of a new type just for methods and saves time and direction on thing here is like if nested captures each environment has a parent, then that is nice. Now we got some docs out of it. How does Fantomas want to format that? Quite enjoying the surprise of just letting it format your code and then finding out what it thinks you should do. And I'm quite happy to just do whatever it wants. Because it does tend to do a pretty good job of making it look nice. Yeah, so in that case, we've actually kind of like this isn't as awkward anymore. So maybe that's enough. But we've still got like I want to. We've got the match effectively on the environment here and the environment here to make links, and we make links in 2 places. Can we get rid of that by computing the size once, matching over the size instead, and then having build environment only be used when it's a standard environment? Yeah, like I think we could probably do that. So if we said, instead of taking the storage list, it just took M size. M size was never 0. Down here, we can say that M size equals, and then that stuff we just copied. N size is going to be captured option map seek some by this. So env mappings, and then in here we can do match env size instead, and we can say if it is sum 0, then we do that. If it is sum size or caps, this just needs to do this, which I think is nicer because we've got rid of an internal compiler error throw thing. Run the test and just make sure it's starting to come together there, I think. So what have we got on this stage to change? What have we done here? So we've all of the information into the kind enum instead. How many times do we call get parent? Because I'm not sure that works. I think this should just return inner here. Can we get rid of the parent environment stuff now? So if we don't need, if no one actually ever calls this function, keep it around because I think that actually needs to be some. Can we get rid of this? Because I think we might be able to. So, because in this case it would be context dot environment and utils get parent. Maybe. Under map. That worked. No. Needs to be option bind, doesn't it? Get rid of that there. I seem to remember we put this in for some really awkward reason, and I'm hoping that we've just managed to refactor that away because I can't remember why it was there. I think it is to do with whether or not we make an instance method or not. So some things failed. Yeah. It's saying it's lambda 1 in Chibi tests. So it's lambda 0. So lambda 1 is this test begin. So why would this not work? I think I remember it being that the outer one has an environment we don't have an environment, and so we don't realize that the outer one does. This is slightly awkward. I can do this bit though. So I think it's when we emit the when we do emit named lambda. Could so that one has an environment there. So we're gonna have a container type, and has environment will return true here. But then later on, we look at the parent environment. This is less has parent end, but it's more like Then down here, we can do is instance. That's awkward because we need to know to be able to. Oh, might work. No, it's not, because if it's an instance method, it would need to be an instance method on the right type. What we got staged. Yeah. I think this is a job for another day. I'll just back all of that out. Let's reformat it again. Check we have not broken anything by reverting it. And then we should commit this change because there's some. This is the unify envinfo and envkind into just envkind. Environment kind. Simplify the representation of environment kinds. We don't need to store the captures. Don't need to store the captures list. And we don't need to mutate. Good. Publish that then. All right. I'm tempted to leave it there today. And I'll have a look in between streams to see whether or not it's worth trying to get rid of this parent environment thing, because we have effectively two parent pointers at the moment. So you have environment, which is an env info, which is either a standard or a link. And if it is a standard, the parent would be inside it. If it's a link, the parent is just directly there. To get the parent environment type, so we shouldn't need it. The problem seems to be to do with where we store the method. So for each emit context, there's the type for the library and the type for the environment. And if when we're emitting a lambda, if it has an environment, we create it as an instance method on our environment. If it doesn't have an environment, we just create it as a static on the current library. But there are cases where a method, where there are cases where we have an environment, but we have a child method that doesn't have an environment. So it could probably go on the library, but at the moment, we're creating it as an instance method on our environment still. So an example of that would be, went into env test again, and say here we had define add a b plus a b, right? So add now exists in the environment of foo. If I go up here and go add, that means that bar needs to capture add from the environment. So add will be the value of add, the like runtime closure instance, whatever you want to call it, the func is going to be stored into a field on foo's environment. So foo will have two things, a and add. And then when bar calls it, it's going to look up a, look up its argument b, and look up add and then call it. But add itself doesn't capture anything, because let's just make this clear by making it I and j. In this case, I and j. We could have add just be a static method on the current library that foo loads in, rather than being an instance method on its environment. There's no need for it to change the environment. There's no need for it to be an instance method. The side effect of it being an instance method will mean, say that we returned add and held on to add. That would mean that because it's an instance method, it would keep the instance of foo's environment live, which means everything else in the environment would be kept live, even though there's no reason to, because add's never going to access it. So that could lead to worse GC performance. And just generally, it's more cruft than it really needs. But it seems awkward to remove just because of some of the the paths that we're going down in the compiler when we choose to omit this stuff. Anyway, it's the Grumpy Game Dev raiding with a party of 2. I'm just wrapping up, to be honest. I was about to go find someone to raid as well. What have you people been up to? Domino raids are fine. Right, let's go find someone to raid. Unless I can motivate myself to do anything else. But I think I've hit a brick wall with this. I just need to go look at other code and I'll have a moment of insight at some point. So you want someone who doesn't have that many viewers. Actually, I mean, let's see about something. Let's see about implementing some more standard procedures. That'll be something to do. So at the moment, we don't have that many. Oh, do I want to save the changes? Probably not. In the moment, in our standard library, we don't have that many things that you can do with strings, which is unfortunate because strings happen quite a lot in programming. So at the moment, we've got string, the string predicate that tells you if something is a string, and we've got the string to number, but according to the spec, there are actually many things that you can do with strings. So I'm just going to get the spec up. And we're going to have a look through what we can do. The main problem here is the fact that strings in CSharp and .NET are immutable. So if I create an instance of a string, then I can't edit it. I can't edit the characters that are in it. I can create new strings and I can slice and dice and concatenate, but I can't mutate the characters in it. Whereas the strings in Scheme are mutable. So I have this. You have this idea of like make string that is a newly allocated string, but that string would then have to be mutable. So at the moment, we only yeah, we only support, well, let's think, like at the moment it is only these two methods that actually deal with strings, because every time we get an argument in this static code where we actually know about the types, we'd call unpack arg. Or unpack args. There's a fairly, yeah, so it's either objects, blah, 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 double. This is like a simpler case of another problem we got in Scheme being like numbers. So ideally we want to represent numbers as being like ints or doubles or whatever, but there's no class hierarchy there, so we'd either have to create a class that represents everything that's a string and use that instead, or anytime that we expect a string, we'd have to like unpack it as just a plain object, And then go on, let's do this. Unpack it as a plain object and then treat it. And then like alternate over either an immutable or a mutable string. But it's not just that simple though, because we have special case handling for strings when we print things, which is going to be in write. So we need to decide what the idea, what a mutable string is going to be. And I guess a string builder is probably the most obvious. So anytime we print them out, we'll do that. So we can print out string builders. And then in strings, so unpack args at the moment. Do unpack arg objects. Well, we already know there's one argument. I guess do on like an unpack string. Let's do an unpack string. I'll do. Well, we can do this as a switch. Switch expression. And if it's a string, S, we'll just return it. The time being. Ravi says, I heard F# was dead. I don't know where you heard that. I heard it's getting better and better. do we want unpack string to do? Probably. Return arg. And then if it is a string, or if it's a string, we'll return that. Otherwise, throw some kind of exception. And let's go to the arg helpers to find out what we expect. Argument exception. Name of arg. That one's to BS. Yep. And this can just do that. Get rid of the return. This is what I was trying to do. I got distracted. So then this can be unpack string arg0. This could be unpack args objects, and then in var that. So this needs a little bit of a helper as well. I guess it's going to be like a try unpack string. Where we're just going to do to be honest, might as well just write this as a chain of ifs. The argument is a string. The argument is a string builder. This can then just be try. If we unpack the string, return the string, otherwise we throw that argument exception from earlier. Well, here we can do like, instead of doing if arg0, we can do if not try unpack string args0 comparand too many closing braces, and then down here we want to say if not try unpack string args I var s. So we have no way of actually creating mutable strings yet, but we should hopefully treat string builders as mutable strings. So if this is going correct, I should just be able to, what a shame. It was close. I was just leading up to say I should be able to run the functional tests. Invert if. String builder. We need system.text, I think. Whoops. Using system.text. So if we can make mutable strings, really, all we need is like the constructor functions to be defined in CSharp. And like string ref and string set so that we can index into them. Then the rest of this stuff, like upcase, substring, append, and that kind of stuff, can hopefully be defined in Lisp. So, did I run the tests? I did the build. Strings.cs. So, we have make string static object make. This can take one or two arguments, either k or k and character. So we say if arg.length is 1, let's what does it say it fills it with? If character is given, then all characters of the string are necessary, otherwise the contents of the string are unspecified. How about that? You can do new string. And you can give it a character and a count. So I guess that's what we're going to have to do. Lan equals int unpack arg double, because we don't support any other numeric types yet, args 0. Fill equals, oh, we can just leave fill as like whatever we decide the default value is. Probably space should do. Else unpack args double char then fill. Can I do this without bar? Can I do landfill equals? Maybe not. Maybe. Return new string builder int capacity. Oh, so create a new one with that capacity. Speed up append new string. Oh, we can just do this. We can just pass in the fill and the len. Return SB. So if I change this to the REPL, will it work? Ugh. Why is it complaining about? Unpack arg does not exist. Unpack args. I'll do that. Double lan. Don't do the cast there. Do the cast here. Mutable strings will be really nice, because one of the things I wanted to do is try and tackle some of the advent of code using Feersum scheme, and it would be really awkward if you can't really do any string manipulation. So that REPL is running. So if I do import Feersum Serifa strings to import the raw one, and then I call mate string window with a string with 100 spaces in. If I do ampersands, nice. And then it's just a matter of doing like string set and having string set only accept string builder, and then having it mutate the string builder, which I think you should be able to do. See, the other idea here that I was wondering about is, do we want to use ropes instead? So it might be better to have like a class hierarchy and treat treat mutation as being like slice the first rope and then splice in the replacements. But I don't really know what kind of good. Yeah. I think it's kind of frowned upon to use too much string manipulation anyway in schemes. So you should be building strings up from nothing. There was talk about making them immutable anyway, because you don't have this kind of awkward situation, because I believe Java has the same problem of strings being immutable, so you have to do some faff to try and work around that. I mean, you could just represent them as character arrays instead. Could we do that? There's probably a lot of places where we'd actually just want a read-only span of characters instead. That's an idea. Let's try it. I guess the question is, what will the string builder API give us? So we've got append, which will put stuff at the end. But we've got like insert. How does insert behave? Oh, we are at the definition. String builder insert. Inserts the string representing the specified into this sentence at a specific character position. Do we have the same kind of equivalent API? There's no requirement for this procedure to execute in constant time. What's that saying? I think that's trying to tell you that you're allowed to use a different encoding. Because if you were, for example, to say, ooh, you'd have to like shuffle the whole, as if you were to represent strings as UTF-8 buffers instead. You'd have to, and you wanted to say like, please set the character 10. You'd have to like iterate through the string to work out where character 10 is, because it would have to be code units. Code points. Text elements, as .NET calls them. Or runes, or whatever you want to call them. But like proper Unicode characters. So if it was a multi-byte character, you'd have to, you wouldn't know, you'd have to skip. I think this is one where a little bit more thought is needed. And it's lunchtime, so I'm going to give up now. But thanks for watching, and hopefully I'll see you next time.